welcome to Science Engineering Academy. This is our video series and we'll be discussing about some common tips, common mistakes what people do in your AEE examination or any competitive examination. Okay. Today let us talk about little bit of stress. What we know about stress. Okay. So many people they have said, sir, stress equal to force per unit area. Then what is your pressure? Pressure is also force per unit area, isn't it? So stress is not the force per unit area. Remember, stress is the what you call internal resistive force. Okay, it's the internal resistive force per unit area provided by the body. For example, suppose this is a cross section I have took, and this is subjected to an external load of P. To this the resistance offered is F. Then the stress is equal to stress. Normally normal stress symbol is sigma. So sigma is equal to your F by A. Okay, sir. Stress is equal to internal resistive force per unit area. But we have seen if the load applied is 50 Newton on an area of, let us say, 10 mm square, we calculate stress as 50 by that area. Means the applied load only we take for the stress calculation. Why then? Why this internal resistive force what you are talking? Very good question. See, I have this material. Okay, just look at me. I can lift this. Okay, you can see this is little heavier. Okay, and I can lift this. This is much lighter. So in both the cases, what my body, how much force I have applied? Yes, come on, how much force I have applied? My force is basing on the application. If I have to lift it, I will be using very less force, isn't it? And that if I have to lift the chair, I have to apply little more force. That means my resistance is depending upon the applied load. If the applied load is P, obviously I am going to resist only P. Where P and F I have shown, this is for external, this is for internal resistive force. But my resistance will be how much? My resistance will be depending on the P. If P, suppose I can resist 100 kilonewton load. How much? 100 kilonewton load I can resist. Okay. The load applied is 20 kilonewton. Obviously I am going to apply only 20 kilonewton resistance. I won't apply for 80 like 100 kilonewton. Try to understand this. My internal resistive force or any body's internal resistive force, any component's internal resistive force is only depending upon the applied load. How much is the applied load? That much only I will give you internal resistance. Okay. So the stress is equal to internal resistive force, per unit area. Unit means 1. Okay. Per unit area, how much is my internal resistive force? These two factors decided my stress. Okay. Let us talk about an example. Okay. A body rests on a frictionless surface. Okay. The load applied is 50 kilonewton, take cross sectional area as 10 mm square. Okay, or little high we can go for no issues. Kilonewton, 100 mm square area you have. So load is given 50 kilonewton. Then your area is given 100 mm square. So what so many people directly they do is, they will go, sir, you said stress is equal to resistive force per area. Okay, stress is equal to resistive force. So sigma is equal to, people will write, because P is equal to F, because my resistive force will be basing on the applied load. So 50 into 10 to the power 3 kilonewton converted to Newton by 100. So here 00, this cancel, remaining is 1. So you will write 500 megapascal. What will you write? 500 megapascal. Stress generated is 500 megapascal. Wrong. Why, sir? Why this is now wrong? You only said resistive force per area. Yes, I said correct. What? Resistive force per area. Applied load is 50 kilonewton. You forgot something here. What it is given? Yes, yes. What it has written here? Frictionless surface. Remember this, frictionless surface. So body, there is no resistance. It's resisting on a frictionless surface, like it's lying on a frictionless surface. So there is literally no resistance for the body. The body will move freely. You are understanding my point? The body is moving freely when you are applying the load. Suppose a tensile load of 100, how much? 50 kilonewton you are applying. So the body is going to move very freely. So where is the resistance here? So unless there is no resistance, no stress. Remember this. So when a body is resting on a frictionless surface, that means there is no stress, because it's not resisting only. The resistive force itself is zero actually. The resistive, no matter what is the area, resistive force itself is zero. Hence the stress developed will be zero. These are some of the things you should remember. Body resists on a frictionless surface. A body free to expand. Suppose you are applying temperature load. What? Thermal stresses you are applying. And the body is not, constrained. It is free to move. Well, it's free to expand in both the direction. What is the stress developed? Zero. So read the question very carefully. See the first line only they will be writing. The body rests on frictionless surface or a body free to move. What is stress? Stress is zero. Okay? Strain will be there. Okay? Strain will be there. So this is one common mistake students do, and I hope you understood this. If a body rests on a frictionless surface or a body free to move, then the stress developed is zero. However, we will be having strain. Strain. And remember, stress is a tensor quantity. See, we have scalar, we have vector, we have tensor. Stress, strain, moment of inertia, these are tensor quantity. T-E-N-S-O-R. Don't get confused. Okay, if exam comes, stress is a what quantity? What quantity? Tensor quantity. Now one small thing will go about strain also. Okay, we'll write about strain. Whenever we talk about strain, I ask students or people, what is strain? They gave me a very straightforward answer. Sir, change in length per original length. Is only change in length per original length is strain? Not like that. Strain is change in dimension with respect to original dimension. Whereas the dimension may be linear, that you call longitudinal strain. The dimension may be diameter, that you call lateral strain. The dimension may be area, which you call superficial strain. The dimension may be volume, you call volumetric strain. Okay, or the dimension may be angle, which you call shear strain. And here my point is, whenever we say strain is change in dimension per original dimension, so people say, sir, strain doesn't have any unit. What they say? Strain doesn't have any unit. Correct, I agree, but not all strains. See, your longitudinal strain, epsilon L, delta L by L, no units. Correct. Your lateral strain, change in diameter per original diameter, no units. Agree. Your superficial strain, change in area per original. Sir, we have not studied where we use this plate. When you have a thin plate, the thickness is so less, which do not consider its volume. We consider the change in area per original area. Okay. And volumetric strain, that is change in volume per original volume. No units. All these cases comply 100%. No problem. Then sir, where is the unit you are talking about? You told strain has a unit. Then which strain has a unit? See this. When I am talking about shear strain, okay, there are some things you should remember. Shear strain. What is this? It is the angular deformation. What deformation? It is the angular deformation where between any two mutually adjacent mutually perpendicular sides. So these two conditions he has to satisfy. You take a block which is fixed here and I am applying a load. Which force? Tangential force. Yes, shear stress, which force? Tangential force. Then this literally the layers will be moving like this. So my A, B, C, D became A prime B, C, D prime, where you can see A, B, B, C mutually perpendicular and C, D, B, C mutually perpendicular. Okay? Can you see this? A, B, B, C mutually perpendicular, adjacent sides. C, D, B, C mutually perpendicular, adjacent sides. What is the first angular deformation? See this angular deformation, theta. Here is one more angular deformation, theta. Okay, what this case is similar. So this is my shear strain. What? Angle. This angle is the shear strain. So here phi is nothing my shear strain. What is the value of phi? It is theta. So it is not delta theta per theta. It is only theta. So only strain which has unit is shear strain. What is the unit? What is the unit of angle? Radian. What is the unit of angle? Radian. Don't say radians, okay? Units are never plural. They are singular only units. So radian. And if you have a numerical where they have given strain in radian, kindly students, please convert it to degree. For numericals, you have to convert it to degree. How to convert, sir? Simple. Pi radian equal to 180 degrees. 1 radian equal to 180 by pi. So theta radian equal to 180 by pi into theta. Convert into degree and proceed. Okay. I hope we are clear with some concepts, some small things here. Like we started from stress and we came to know that stress is always the internal resistive force per unit area. If there is no resistance, there is no stress. For example, body rests in a frictionless surface, body free to expand, there is no stress. Then we came to strain. We decided strain is change in dimension per original dimension. The dimension may be length, diameter, area, volume. All these cases, these are the ratios and they do not have any what? They do not have any units. That means they are dimensionless quantity. But when we come to shear strain, it is the angular deformation between any two mutually perpendicular sides, and those two sides are adjacent. Adjacent, mutually perpendicular sides. Angular deformation means it's not a ratio, it's a deformation in the angular force, theta. So this theta has a unit, radian. So that's why shear strain, only strain which has unit is shear strain. And what is the unit? Radian. Suppose we come across stress strain, Young's modulus is there, strain is given in terms of radian, shear strain is given. Okay, then tau, shear stress is given, strain is given, and your shear modulus is there. So in that case, the strain you convert into degree. And how to convert radian to degree? Pi radian equal to 180 degree, 1 radian equal to 180 by pi, theta radian equal to 180 by pi into theta. Convert it to degree, then proceed. Don't mistake in this. Okay. One more last thing I want to add here. See this volumetric strain. That means volume is changing. Now can you tell me, out of shear stress and normal stress, which changes volume? Yes. Remember, if I will apply normal force or normal stress is generated, it will change shape obviously, and it will change the volume. Only normal stress changes volume. Shear stress only changes the shape. It has nothing to do with the volume. Okay, shear stress or shear force never changes volume. It only changes the shape. However, normal stress or normal force changes shape and size of the cross section as well as volume. Okay, I hope this lecture is going to help you in future. Thank you.